All right, today what we are going to talk about are graphing exponential functions. So we're going to take what we've learned before and put it on a graph. So the graph of an exponential function is a curve. So it'll either curve up or it'll curve down, but it is not a straight line. It is a curve. And the y-intercept can be found by substituting in 0 for x. And horizontal asymptote is an imaginary boundary of y equals axb to the x power, and that imaginary line is y equals 0, since y is greater than 0. So an asymptote is an imaginary where the graph gets closer and closer, but never touches. So it gets really, really close. Now think of it as a force field. It can't go past there. So your exponential growth, if b, or the common ratio, is greater than 1, and exponential decay, if b, or the common ratio, is between 0 and 1. Now your domain for your exponential functions are going to be all real numbers, and again, you can, the symbol for that, it looks like an R with 2 of the lines there. And then the range is y is greater than 0. All right, so when you're graphing by hand, it's important to make sure that you do the formula right here. And remember, we said A is the y-intercept. And we're going to multiply the growth factor going left to right, or multiply by the growth reciprocal if we're going right to left. So I'll show you what I mean for these two. All right, so let's start with this first one. Looking at this equation, your y-intercept is your A value, and I color coordinated it for you. So A is your y-intercept. So our graph is going to cross the y-axis at 8. Your growth factor is 2, and since this growth factor 2 is greater than 1, it is going to show growth. So it's going to get bigger. Now, this one, your horizontal asymptote, is y equals 0, so you're going to put that in there. All right, so now we're going to take all of this information right here, and we're going to graph it. Now, I already have the graph on here for you, but I'm going to show you what it looks like. So here's what we did. I'll give you the points and how we got the points in a second. But first off, if you notice here in red, it's a dashed line on the x-axis. Well, this is your horizontal asymptote, and it's when y equals 0, because your horizontal asymptote will cross the y-axis at 0, and this is where your curve is going to get super close, but never cross. All right, so first I graphed my horizontal asymptote. Now I'm going to plot my y-intercept, which is 8, and now we have to figure out the points to go from there. So I made a table. So with this table, we said our y-intercept was 8, and we said our growth factor is 2. So we're going to ignore these for a second, and we're just looking at your positive numbers going this way. So when we go this way, we're multiplying by 2. So 8 times 2 is 16. 16 times 32, or times 2 is 32. Well, now that we've got that, now we're going to go the other way, and we're going to do the opposite. So since we're going backwards, here we are multiplying by 2 going this way, so you're going to divide by 2 going that way. Or you can think of it as multiplying times 1/2, because that's the reciprocal of 2 over 1. So we're going to multiply by 1/2 or divide by 2, and we're going to get 2. So now that we have our points, and again, I'll put both ways on there, or if we multiply by the reciprocal, oops, because we flipped, because this is technically 2 over 1. All right, so now let's go ahead and let's plot our points. So we already plotted our y-intercept. And then now, just go ahead and plot your points. Now, obviously, since this counts by 4, we're going to have to approximate where these two go. But I know -2, 2 is about midway there. And I know -1, 4 is right there. We already plotted our y-intercept. And then here, we got 1, 16, and 2, 32. Now, again, when you graph this, it's going to get really close to your asymptote, but it is not going to cross it. And then you're just going to go through, and it's going to curve upwards, and that's your graph. All right, so now let's look at this one. So we have an exponential function of y equals 4 times 3 to the x power. So this is our y-intercept. So it's going to cross the y-axis here. This is our growth factor because it's attached to the exponent x. Our horizontal asymptote is still y equals 0. And since 3 is the greater than 1, your graph is going to show growth. So let's go ahead, let's plot our points. I know right away our y-intercept is going to be 0, 4. All right, so when we're doing this, we're going to ignore these guys for a second. We'll come back to there. When we're doing this, we're going to actually take, I'm going to erase these real quick. All right, so when we're going this way, if your growth factor is 3, you're multiplying everything by 3. All right, so we got 4, 12, 36. Now we're going to ignore these for a second and we're going to go backwards. So since we're going backwards, if we are multiplying by 3, you're going to multiply by the reciprocal, which would be times 1/3 times 1/3, which I said is the same as if you're dividing by 3. So you could divide by 3 or multiply by 1/3. Either way works. All right, so you're going to get a decimal on this one, and because you're going to get 4/3, which is approximately 1.3 repeating, and then here it's 0, take 1/3, multiply it by 0.33 or divide by 3, and you're going to get 0.4. So again, let's first plot our asymptote here, and remember, it's going to cross the y-axis at 0. And that's a dashed or dotted line. And then now let's plot our points. We're going to get really close but not touch the line. -1 is going to be 1.3. That's about right there. Our y-intercept is right here. And then we have 112 and 236. So again, we're going to get super close to your asymptote but not cross it. And now we're going to go through and we're going to graph our points from there and then put the arrows on the end. And that's your graph for those two. All right, so now let's look at some where it's a little different, but the same process as far as format. 2 is your y-intercept. 1/2 or 0.05, this is your growth factor. Your horizontal asymptote is still y. Now, since your growth factor is 1/2 and it's less than 1, you're going to show decay. So let's check here. Again, we're going to graph our asymptote. And I'm going to first plot my y-intercept at 2. And I'm going to write it in here. So when we're going this way, if your growth factor is 1/2, you're going to multiply by 1/2. Each time, and you can either write 1/2 or 0.05. And then now, if we go backwards to flip 1/2, you're going to get 2/1. So to go backwards this way, we did the reciprocal. So we're going to multiply by 2, multiply by 2, and then now we have all our points. So after we've graphed our asymptote, we're going to graph our y-intercept, and then go ahead and -2, 8, -1, 4, and then 1, 1, we're going to approximate to be about there, and then 2 and 1/2. Now, if you notice, the curve is going to go down and around. Now, that's not like the straightest line, but you can see where it's curving down as opposed to the other way that went up. So this is decay. And then right here. And then when we went this way, this is growth. So you can tell what direction or what's happening based on the graph. All right, so now let's go ahead and let's check this one. So for this one, 9 is your y-intercept, 1/3 is your growth factor, and horizontal asymptote is 0. And since 1/3 is less than 1, we've got decay, so we know our graph is going to look like that. All right, so our y-intercept was 9. We said our growth factor is 1/3. So when we go this way, we're multiplying by 1/3. We're multiplying by 1/3. And to go backwards, if you were to flip 1/3, you get 3. So we're actually multiplying by 3, multiplying by 3. And now that you have your points, graph your asymptote, y equals 0. And that's your imaginary line. Now we're going to plot our y-intercept, which is at 0, 9. And then go ahead and let's plot the other point. So negative 127. This one is off the graph, so we can't really plot this one. But we can graph this one here. We got 0, 9. 1, 3 is about right here. And then 2, 1 is about right there. And then you're going to go ahead and you're going to connect your points. And it's not a straight line. It is not going, we are not doing that. It is a curve. And it's going to get super close to your asymptote, but not touch it. All right. So what I want you to do, go through, finish the rest, and then check your answers. But here, there's one important part I want to show you. If you look at your formula, it's just this to the x power. There is no number written before in front of it, so this is really 1 times 3 to the x power. Or we can rewrite it, I'll rewrite it here. Y equals 1 times 3 to the x power. So just remember when you're doing this, if there's no number written, then your y-intercept is going to be 1. So just be careful with that. And then growth factor is 3. Horizontal asymptote is this. And since it's 3, it's going to be growth. So your curve is going to curve up. Oops, sorry. It's going to curve up like that. All right. So go ahead, plot your points. And since it's 3, you're going to multiply by 3. And then backwards, if you're multiplying by 3, this means you're going to multiply by 1/3, going that way, or divide by 3. All right, and if you graph it, that's what it should look like if you did it correctly. And then go ahead, see they tried to trick you again. If there's no 1 written, put a 1 in there, and that is your y-intercept. All right, so go ahead, complete the rest of the information. And then, and then that's what your graph should look like. And that is exponential functions graphing.